Section 11.1. Can you believe it? Chapter 11 already?
Yes.
I think we actually might finish the book. I have not ever finished this textbook, but we are on pace to actually finish the textbook this year. All right, so in 11.1, we're learning about square roots. When you think of the root of something, name me something that has a root. A plant. A tree.
A carrot.
A carrot. Very good. Carrots have roots.
Potato.
And where are the roots? Are the roots on top of whatever it is? Where are the roots? Hey, guys, listen. Where are the roots? They're in the ground. They're in the bottom. They give the plant or the tree life, right? They absorb the nutrients and send the nutrients up into the plant. So roots are the foundation or the base of whatever it is that it's feeding. Well, really, the same thing applies with square roots and numbers. That number, the square root, okay, of a number is its base. It's the number that can be multiplied by itself to equal some other number. So let's think about the square root or the base of 64. What number can be multiplied by itself to equal 64? 8. 8 times 8 equals 64. So because 8 times 8 equals 64, then 8 is the square root, or our base. What about 81? 9 times 9. So 9 is the square root. What about 36? 6. What about 4? What about 1? 1. 1 times 1 is 1. 1 technically is a perfect square. All right, so that's square roots. All right, second slide. Perfect squares. Now, a perfect square is kind of on the other end. It's the product. It's the answer. A number times itself that equals some number, that number is a perfect square. So perfect squares have factors of numbers that can be multiplied by themselves to equal that number. All right, so 4 is a perfect square because 2 times 2 equals 4. 9 is a perfect square because 3 times 3 equals 9. 16 is a perfect square because 4 times 4 equals 16. Can someone else think of a number? Can someone think of a number that has a factor that can be multiplied by itself to equal that number? Think of another number. So what about 20? Does 20 have a factor that can be multiplied by itself to equal 20? 4 times 4, no. 5 times 5, no. Okay, so what's 10 times 10?
100.
So 100 is a perfect square. What's another perfect square?
200.
Nope. It's got to be a number that has a factor that can be multiplied by itself to equal it. What else is a perfect square? 25, because what?
81.
No, let's stay with 25. Why is 25 a perfect square? Because 5 times 5 is 25. Give me another one. 36. Why? Because 6 times 6. We already said 25. Okay. 49. Because what? 7 times 7 is 49. Give me another one. 64. Because 8 times 8. Okay, so those are perfect squares if they have a factor that can be multiplied by itself. Does that make more sense? All right, so now let's talk about radicals. See that radical sign that I just highlighted? That represents a square root. Anytime you see that, you know you're taking the square root of whatever's underneath it. It is positive unless you see a negative sign in front of it. Radical signs are positive. All right, so this is what this means. What's the square root of 25? 5. What's the negative square root of 25? Negative 5. So if you see this negative sign out in front of the radical, all it means is that your answer is negative. What if it was a double negative? It'd be a positive. All right, you won't see that. You won't see that on your homework. All right, so now let's kind of start putting it all together. Finding square roots. Find the how many? 2 square roots of 81. Well, why are there 2 square roots? Well, it's because what's 9 times 9? 81. What is negative 9 times negative 9? Positive 81. It's 2 negatives. That's an even number of negatives. So that's why my answer is positive and negative 9. It's 2 answers, 2 square roots. It's the positive and negative version. Why? Because a negative times a negative is still a positive. It's still a solution. All right, now, you don't have to show this on your homework tonight. The 9 times 9, negative 9, but you need to understand the why behind it, okay? Fair enough? So this is your answer in red. That's all you have to write. So now I want you to do the second one. Find the 2 square roots of 49. Right? What is it, guys?
7.
It's positive and negative 7. So if all you say is 7, it's wrong. No credit. Because it's not just 7. It's positive and negative 7. So now I want you to find the 2 square roots of, of 361. 361. So this one's a little harder. We can't really do it mental math, but we can use what? Our calculators to find the square root. And then don't forget, it's both positive and negative because there's no radical in the original, and I know that both can be solutions. So what's it going to be, guys?
19.
Positive negative 19. Don't forget, if you forget this symbol, this positive negative symbol, do you get any credit? No, you don't get any credit. Positive negative 19 is that answer. All right, so that's how we find the square roots. Now, what if we already have a radical? So on these problems, there is a radical in the original problem. So since there's a radical there, what did I tell you? The radical is positive or negative? Just a radical. It's positive. Unless there's a negative sign in front of it, then my answer is negative. Go ahead and find the square roots of each of these numbers. They will not be positive, negative. Why? Because the radical is positive, unless you see a negative in front of it. So what's the square root of 36? 6. What's the square root of 16?
4.
What's the square root of negative 16? What about 0?
0.
What about negative square root of 625? Negative 25. Just don't forget that negative, guys. Who got them all right? All 5. Did you get all 5 right? All right, any questions? Okay, so that's how we evaluate square roots that have radicals. What if we're evaluating square root radical expressions? So now there's actually work to be done underneath the radical. I have to make a substitution and then evaluate. All right, so go ahead and plug in your value for z and then take the square root. What do I substitute for z? What value?
7.
So 29 plus 7 is what? What is it? 36. So square root of 36 is 6. Now, why isn't my answer positive, negative? Why is it just 6? Because there's a radical. There's a radical in the original problem over here. Did you see a negative out in front of it? No. So my answer is just 6. Do you see the difference, guys? When you have a positive, negative, and when you don't, that's one of the main mistakes I see on this quiz, is they try to say positive, negative 6. It's not, because there's a radical in the original problem. Now, the second one is considerably more involved, right? I'm squaring numbers. All right, try to make your substitutions and solve that one. All right, so if your mistake happened, it probably happened with squaring the negative, because what's negative 2 times negative 2? positive 4. Now, guys, if you put it in your calculator, you have to put the negative 2 in parentheses. If you don't, it's going to give you the wrong answer. You have to put these negatives in parentheses when you square them. And then when you square it and find the square root, you get 8. 8.
I didn't even put the negative. I got it.
Okay, well, you got lucky because a negative squared is just going to be positive. So that's why you still got the right answer. All right, but you do need to make sure you have that in there. So that's evaluating radical expressions. Now let's talk about equations. Solving equations using square roots. Now with these equations, remember opposite operation? It's been a while, but you guys remember this? 3x equals 12. Remember that? 3x equals 12. How do I solve for x?
You gotta subtract.
Nope. You don't subtract.
3s over 3.
Yeah, you have to divide, right, to get x equals 4. Because what is my core foundational principle to solving equations is I use opposite operations. You guys remember that? So if it's multiplication connected, I divide. If I'm connected by division to my variable, I multiply. If I'm adding, I subtract, right? Opposite operations. So now let's go back to A. Now I have an exponent connected to my variable. So the opposite of squaring a term is to take the square root. So since I'm squaring x, in order to get x by itself, I have to take the square root. Okay? Whatever I do to one side, I do the exact same thing to the other side. Take the square root of both sides. So now let me ask you this. What is the square root of 25? 5. X equals positive and negative 5. So let's talk for a minute about why my answer is both positive and negative. Well, it's obvious that 5 times 5 is what? 5 times 5 is 25. Yes, correct. But what is negative 5 times negative 5? It's positive 25 too. So because both of these guys come out to an answer of positive 25, that's why my answer is both positive and negative. Does that make sense? So when I plug it back in, the positive version of that number works, and so does the negative version of that number. So that's why my answer is both positive and negative. What about B? H squared plus 5 equals 54. This is a two-step equation. So do you think I need to take the square root of all 3 terms first? Or would I want to move what's not connected to the variable first? What do you think? You think it's going to be fun to take the square root of 5?
No.
Nope. So what you can do instead is you can move 5 to the other side of the equation. Move what is not connected to the variable first. How do you get rid of positive 5?
Subtract.
You subtract it. And you know what's really nice about these guys is a lot of times it works out really evenly. What's 54 minus 5?
49.
Ooh. Can I take the square root of 49?
Yes.
Yeah. What's it going to be?
7.
Nope.
Positive negative 7.
Positive negative 7. Why positive and negative? Why both?
Because it can be positive and
Because I can plug in a negative 7 back into the original, and what's negative 7 times negative 7? Positive 49 plus 5 is 54. So it still works out. Think you can do one? Yeah, you think you can? Okay, so you do this one. I do first.
you're gonna subtract. I'm gonna add.
You're going to add 3 to both sides. B squared equals 25. Then what do?
You
You're gonna
do the square 25.
Find the,
And then you're going to do B.
You're going to take the square root of both. What's your answer? Nope.
Negative.
Positive negative 5. And it's positive negative because if you plug in negative, it still works out. All right, so now let's do this one. What if you were solving 11x squared equals 891. So what are you going to do first to both sides?
You're gonna divide 11 by
So the square root, guys, is the last thing that you want to do. First thing you want to do is divide both sides by 11. So when you divide both sides by 11, what's 891 divided by 11?
81.
X squared equals 81. Well, that's nice. When you take the square root of both sides, what do you get?
9.
Nope.
Positive negative.
Positive negative 9. And why is it both positive and negative?
You can put a negative.
Because it still works out, yes. Okay? Still works out because negative 9 times negative 9 is still positive 81, and 11 times 81 is still 891. And if you understand that, that's everything you need to know for 11.1.